Hey guys, welcome back to Algebra 1. We are on to polynomial equations and factoring. This is going to introduce you to quadratics as we learn how to add, subtract, and multiply polynomials. We're going to learn how to factor them, and we're going to learn how to solve polynomial equations. Okay? So there's a lot of stuff that we're going to be talking about here. So what is a polynomial? Well, to understand what a polynomial is, you must know what a monomial is. It is any number, variable, or product of a number and or variables with whole number exponents. So these guys right here are polynomials. They got coefficients, they got variables, one's a constant, all the exponents here are whole number exponents. Alright? So, and then the degree of a monomial is the sum of the exponents of the variables. Alright, so let's take a look here. See, we can find the degrees of these monomials here. Alright, so 5x squared, that's your first one. So to find the degree, we must only look at the exponents. So we have only one variable with an exponent. So, and if we look at the exponent, that's our degree. 60 exponents 2, our degree of 5x squared is 2. Alright? For this one right here, we have negative 1/2 times xy cubed. Alright, so there's two variables going on here. Now, we're talking about the sum of the exponents here. Now we just have an x, so what does that mean? Well, you see you have just x, right? You can't rewrite this as, okay, it's not going to let me do it, whatever. Okay, that was stupid. But anyways, we could have rewritten it as x to the power of 1, it just didn't let me. So sum of the exponents is the degree of this monomial here. It's going to be 1 plus 3. Dang it, I did it again. I hate this thing. So 1 plus 3 equals 4. So the degree of this monomial is 4. Alright, and then for here, we got two variables again. So we got x cubed and y cubed. It's two exponents, we add them together, we get 6. And so the degree of the monomial is 6. Alright? Now what about this one? Well, let me tell you this right now. This is indeed a monomial. Might have no variables, but it's still a monomial. And still got a degree. Alright? So what can we do? Well, the degree of the monomial is 0, because you can rewrite this as negative 3x to the power of 0, and anything to the power of 0 is 1, right? So your degree is 0. Now here's the catch. This is not very significant, but if you tried to find the degree of 0 and you said 0, guess what? You're wrong. The 0 has no degree at all. I have no idea why, but it's just that weird. Alright, now you got a ton of vocab here. As we move into the next section. Okay, so polynomials. That's any monomial or sum of monomials. So all this stuff right here, I need to clear that one out. So all this stuff right here we're looking at is polynomials. And we're going to be looking at all polynomials throughout this entire unit, okay? To get used to me saying polynomials. Alright? Binomials. That's a polynomial with two terms. In this unit, you're going to be learning how to add, subtract, and multiply polynomials. When we get to multiplication, most of what you're going to be doing is binomials. You get into some more trickier stuff when you get to algebra 2. Okay? We'll talk about it briefly, but it's not going to be as significant as what we're going to do in Algebra 2. Okay? Anyways, trinomials. Those are polynomials with 3 terms. So in this chapter, we're going to be learning how to factor trinomials. That's the main kind of polynomial that we're going to be learning how to factor. We're going to do a quick video on more advanced polynomials later, but most of what you're going to be doing is quadratics. Primarily just to prepare you for the next unit, which is on quadratics. Okay? And then the degree of a polynomial is where you can look at the degrees of each term, each monomial, each part of it, and whichever monomial has the greatest degree, that's your degree of the polynomial. Alright? Now, many teachers would like to ask that you write your polynomials in standard form throughout this unit. And standard form is where the exponents decrease from left to right. Alright? So, if we have a 4 minus x squared plus 3x, that is not in standard form, because we got the degree of the polynomial, the term that has the degree of the polynomial as in the middle of the polynomial instead of the beginning. We need to write it as negative x squared plus 3x minus 2. I don't remember what the concept was that I said, but we'll explain it later. And then, alright, so if you put the polynomial in standard form, you're gonna get you might want to take a note of the leading coefficients. And the leading coefficient is, when put in standard form, it is the first coefficient of a polynomial. Polynomial, only when it's in standard form. Now, we're not going to worry too much about degrees and leading coefficients in Algebra 1, but when you get to Algebra 2, degree of a polynomial is going to get pretty important when you're graphing the functions. We're not going to do those at all this year. But you're going to learn how to graph them, and you're going to need knowledge about degrees of polynomials in Algebra 2. And then leading coefficients, that's going to be pretty important when you get to irrational functions in Algebra 2 or pre-calc, whatever your teacher decides to do. But anyways, we're just going to learn how to classify polynomials. Alright, so we're just going to examine these 3 polynomials here. So first one, negative 3z to the power of 4. Alright, so this one's pretty basic. I would have to ask that you write all these in standard form, but this one is already written in standard form. Because it is a monomial. Alright, now I'm just going to write that down. Alright, now I'm going to have to ask that you classify this polynomial and based on its terms. Because this is only one term, this is a monomial. The coefficient is negative 3 here, and so the leading coefficient. Why does it make me turn on sticky keys every single time? The leading coefficient is negative 3. Alright, and the last thing is, what is the degree? Well, that's pretty easy. You just look at the exponent, and the degree is 4. Alright, now, that was pretty easy though. Let's try some of these. This one. This polynomial is not in standard form. We need to rewrite this. So the first thing we write down when putting a polynomial in standard form is the term with the greatest exponent. And so it's going to be 5x squared. The next largest exponent is negative x, which has an exponent of 1. And then constants go last. And then now we got to classify this polynomial based on its terms. This has 3 terms. So we're looking at a trinomial. All right. Now we need to find the leading coefficient. We need to look at the coefficient that's in standard form. So it's not 4, it's 5 for 5x squared. And so your leading coefficient is 5. And the degree of the polynomial, that is the greatest exponent that you can find. And that is 2. 2. So basically, when you're trying to find the degree of a polynomial, you simply need to look at the first term when it's in standard form. So the degree is 2. Alright? Now I want you to try this one. 8 cubed plus q to the 5th. I want you to rewrite this in standard form because it's not. Classify the polynomial by its terms. Identify the leading coefficient and degree. Okay? So pause the video and think this out on your own. It's really easy, guys. Don't worry. Okay, so let's see what you get. So this is not in standard form, so we need to reorganize the terms from highest exponent to lowest exponent. This one's pretty easy because it's only got 2 terms. So it's going to be q to the 5th, because that's your highest exponent, and then 8q goes second. This has 2 terms, so we are looking at a binomial. And then, since we got this in standard form, we can easily find the leading coefficient and degree. And so, notice that there is no coefficient right next to the first term. However, when that happens, it doesn't mean that the leading coefficient is 0. It means that the leading coefficient is 1. Alright, and then the highest exponent is 5, so the degree is 5. Alright, so that's pretty much the basics of polynomials. Now, are you ready to perform some operations with them? Alright, well, I hope you aren't, because we're going to get down to it right now. Alright, so here's a problem that I'm going to be working out for you. So, way we add polynomials is we simply need to combine like terms. You may have learned about this in your middle school algebra stuff. Okay, so we are simply combining like terms here. So, first thing we need to do is look at the degrees. Degrees of each polynomial. Because we're going to be writing this out in standard form. The highest degree that we can find is what we write first, and the highest degree we can find is 3. So it's going to be x cubed. There are a couple x squareds, so I'm going to put in plus x squared. Now I might have to change those signs, guys. Guys, I'm just writing out the variables so we don't miss any. Okay? And then we just got a lone x on the first term, and then I know this is going to be -1. Alright, so the last 2 terms won't change, but I know that the first and second terms need worked out, okay? So, we need to find the x cubes. So, first one right here is 2x cubed, 2, and then right here is x cubed, that's 1x cubed. So what we're really doing is just taking 2x cubed plus x cubed, which equals 2 plus 1. So it's going to be 3x cubed. Now we examine the x squareds. This is going to be -5 plus 2. So it's going to be minus 3x. See why I had to change the signs here? I just thought I'd write it out this way so we can make things a little bit easier. Alright? Now, why don't you try one out on your own? Try to use the same process that I made. Write out your variables and their exponents, and then add your coefficients together. Okay, so let's try it out. Looks like the highest variable term we can get is x squared. And then we're going to have an x. Then it's going to be an easy look at the constants here. It's negative 6 plus 10, which equals 4. Alright. And now we look at the variable terms and add them together. So it's going to be 3x squared plus x squared. Always add like terms. So its coefficients are 3 and 1, so it's going to be 3 plus 1, which equals 4. Now for the x terms. It's going to be x plus 4x. That's going to be 5x. And then there's your answer. That's pretty easy. That's pretty easy, right? Well, wait till you see subtraction. Alright. So this one can get a little bit frustrating for people, and it can be frequently missed by beginner level students. However, if you just remember one thing, you always need to think about opposites. Remember when back in middle school when you had to learn about integers? An integer minus an integer is the same thing as adding the other integers opposite. That's basically what we're doing here. It's the exact same thing. So what we can do is actually rewrite this entire expression here. So it's going to be 4n squared plus 5, keep it as that. As for the second term, we need to reverse the signs on every single term. We're going to change this to a plus sign. Opposite of negative 2n squared is 2n squared. Opposite of 2n is negative 2n. Opposite of negative 4 is plus 4. Very well. Very well done. Now we can just add them together in peace. So we're just going to write out the variable terms again. This one's a loner. And then 5 plus 4 equals 9. So always make sure to write this out. Write your variable terms out so you don't miss anything. This is very important for when you get to more complicated problems like in Algebra 2. I know that my Algebra 2 teacher gave me some pretty complicated addition, subtraction, and multiplication problems, and that's why we're writing these out first. Okay? Alright, so now we just need to combine the n squared terms. So it's going to be 4n squared plus 2n squared, which equals 6n squared. So 6n squared minus 2n plus 9. That is our answer. Pretty simple.